believe we're on to chapter 7. Chapter 7. I think I already have it open. And I believe that is packages, crates, and modules. Close that. So, packages, crates, and modules. A key question when writing programs is scope. What names does the compiler know about at this location in the code? What functions am I allowed to call? What does this variable refer to? Rust has a number of features related to scopes. This is sometimes called the module system, but it encompasses more than just modules. Packages are a cargo feature that let you build, test, and share crates. Crates are a tree of modules that produce a library or executable. Modules and the use keyword let you control the scope and privacy of paths. A path is a way of naming an item such as a struct, function, or module. This chapter will cover all of these concepts. You'll be bringing names into scopes, defining scopes, and exporting names to scopes like a pro soon. Yeah. All right, let's move on to the next section. This one's really small. It's the next one where we get all the stuff. So, packages and crates for making libraries and executables. Let's talk about packages and crates. Here's a summary. A crate is a binary or library. A crate root is a source file that is used to know how to build a crate. A package has a cargo TOML, T-O-M-L file that describes how to build one or more crates. At most, one crate in a package can be a library. So when we type cargo new, we're creating a package. And here's our example. We've done this before. Cargo new, when we create a new file in our editor, it creates a new package. And we get the list, and we have the cargo file, source file. Here, let me just pull up a editor real quick so you can see it. Open this. So we have the source file, the cargo file with the lock. And in the source file is the main file. Things like that. That's what they're showing us. Put that back. So because cargo created a cargo TOML file, that means we now have a package. If we look at the contents of the cargo TOML file, there is no mention of the source main.rs file. However, Cargo's conventions are that if you have a source directory containing main.rs in the same directory as the package cargo TOML file, Cargo knows this package contains a binary crate with the same name as the package, and source slash main rs is its crate root. Another convention of Cargo's is that if the package directory contains source / lib.rs, the package contains a library crate with the same name as the package, and source / lib.rs is its crate root. The crate root files are passed by Cargo to Rust C to actually build the library or binary. A package can contain 0 or 1 library crates and as many binary crates as you'd like. There must be at least one crate, either a library or a binary, in a package. If a package contains both a source / main.rs and a source / lib.rs, then it has 2 crates, a library and a binary, both with the same name. If we only had one of the two, the package would have either a single library or binary crate. A package can have multiple binary crates by placing files in the source / bin directory. Each file will be a separate binary crate. Now, let's talk about modules. Okay. Just to summarize real quick, they say if you put it in one location, the source / main, then you have a binary crate. If you put stuff in the source / lib file, then you have a library crate, and you can have both a library and a binary crate in one project if you wanted to, but you don't have to. Or you can just have one or the other. And you can have as many binary crates as you like, but you can only have 1 or 0 library crates in a project. At least that's what I read. Thought I read. Understood. That's what I understood. Next, the module system to control scope and privacy. Rust has a feature that's often referred to as the module scope, but encompasses a few more features than modules. In this section, we'll talk about modules, a way to organize code and control the privacy of paths. Paths, a way to name items. Use, a keyword to bring a path into scope. Pub, a keyword to make items public. Renaming items when bringing them into scope with the as keyword. Using external packages. Nested paths to clean up large use lists. Using the glob operator to bring everything in a module into scope. How to split modules into individual files. First up, modules. Modules let us organize code into groups. Listing 7-1 has an example of some code that defines a module named sound that contains a function named guitar. Here, just for parity, we should probably write this out. Let me create a new project, call it sound. Just in case they have me import something, I need to have a project. This is going to be called sound. I'm going to create it. I'm going to open it now. Go to the main file because that's where they put this stuff, right here. Source main. And in here, their main is, well, theirs is empty, mine isn't. But I can do module sound, seemingly. And then in sound have a function called guitar. And theirs is empty. I'm gonna have mine print something just so it does something. Sound. Oh, sounds like a guitar. It's like a guitar. All right. So I wrote what they have here. We've defined two functions, guitar and main. We've defined the guitar function within a mod block. This block defines a module named sound. So here's the mod block, and we have the module named sound. And within it, we have a guitar. Okay. To organize code into a hierarchy of modules, you can nest modules inside of other modules, as shown below. So here's something else they did, which is similar. It doesn't have guitar here anymore, but they have sound. They have another module called instrument, another module called woodwind, and within woodwind they have clarinet. And then here's another module which is nested under sound. So under sound has instrument and voice, and then within instrument we have woodwind and then clarinet. So that's just showing an example of nesting them. Makes sense? In this example, we've defined a sound module in the same way as we did in listing, the one above it. We then defined two modules within the sound module named instrument and voice. The instrument module has another module defined within it, woodwind, and that module contains a function named clarinet. We mentioned in the packages and crates for making libraries and executable section that source/main.rs and source/lib.rs are called crate roots. They are called crate roots because the contents of either of those two files form a module named crate at the root of the crates module tree. So in listing 7-2, the one above, we have a module tree that looks like this thing down here. Crate, which is going to be the root, which is, as they said, it's this main file for us, or it could have been a libs file if we had something in libs, like source lib.rs. But for us, it's main. So this is going to be called crate. And then within crate, they have sound, which we have here, but we didn't write everything else. Instrument, woodwind, and they have voice. All right, that's straightforward. This tree shows how some of the modules nest inside one another, such as woodwind nests inside instrument, and how some modules are siblings to each other. instrument and voice are both defined within sound. The entire module tree is rooted under the implicit module named crate. This tree might remind you of the directory tree of a file system you have on your computer. This is a very apt comparison. Just like directories in a file system, you place code inside whichever module will create the organization you would like. Another similarity is that to refer to an item in a file system or module tree, you use its path. Now they should be explaining path to us, okay? Paths for referring to an item in the module tree. If we want to call the function, we need to know its path. Path is a synonym for name in a way, but it evokes that file system metaphor. Additionally, functions, structs, and other items may have multiple paths that refer to the same item, so name isn't quite the right concept. A path can take two forms. We have an absolute path, starts from a crate root by using a crate name or a literal crate. A relative path starts from the current module and uses self, super, or an identifier in the current module. Both absolute and relative paths are followed by one or more identifiers separated by the double colon. So how do we call the clarinet function in the main function listing in 7-2, the one all the way up there? That is, what's the path of the clarinet function? In listing 7-4, let's simplify our code a bit by removing some of the modules, and we'll show you two ways to call the clarinet function from main. This example won't compile just yet. We'll explain why in a bit. Alright, I'm going to write out this example, and I know it's not going to compile because they said it's not going to compile, but looks like it's going to compile later on, so better start now. So we're creating nested modules. Instrument is within sound. Instrument. And then when in here we have a clarinet, which is print clarinet sound. Clarinet sounds. Alright, and in main they're using both the absolute path and the relative path. So the absolute path would be crate, which they simplified for us there, sound, which we can see there. Everything's being auto-completed. Instrument isn't being auto-completed though, so I guess I have to write that out myself. Instrument and clarinet, and then call it. I should probably put the comment. So this is absolute path, and then here we go, write relative path. And that's going to start from sound. Instrument, clarinet. But this doesn't compile. We'll find out why in a little bit. I guess we could run it now, but the error's down here. So the first way we're calling the clarinet function from the main function uses an absolute path. Because clarinet is defined within the same crate as main, we use the crate keyword to start an absolute path. Then we include each of the modules until we make our way to clarinet. This is similar to specifying the path sound, well, /sound/instrument/clarinet to run the program at that location on your computer. Using the crate name to start from the crate root is like using the / to start from your file system root in your shell. The second way we're calling the clarinet function is from the main function using a relative path. The path starts from the name sound, a module defined at the same level of the module tree as the main function. This is similar to specifying the path sound/instrument/clarinet to run the program at that location on your computer. Starting from a name means that the path is relative. So yeah, what they're basically saying is that, and at least in comparison, when the file system, if you start off with a slash, then you're starting off from the file system root. And for Rust, that file system root, at least for a crate, would be crate. And if you did not have the / at the very beginning, then you're starting off from a relative path, which in this case would be sound, because this is defined in the same level as main, so they can just reach out to each other. We mentioned that the code wouldn't compile. Let me see if I get the same error. Cargo run. What do you tell me? What do you tell me? What do you tell me? Instrument is private. So this is probably where they're going to tell us about the pub keyword. Yeah, they have the instrument is private. The error messages say that the module instrument is private. We can see that we have the correct paths for the instrument module and the clarinet function, but Rust won't let us use them because they're private. It's time to learn about the pub keyword. I'm going to take a stab at it. Let's say pub. I don't even know if sound is private or public. Well, let's see if that did anything. Get rid of this. And that seems like that's all I really had to do. Add public here and here, and they're now public. Okay. Modules as the privacy boundary. Earlier, we talked about the syntax of modules and that they can be used for organization. There's another reason Rust has modules. Modules are the privacy boundary in Rust. If you want to make an item like a function or struct private, you put it in a module. Here are the privacy rules. The rules are: all items, functions, methods, structs, enums, modules, and constants are private by default. You can use the pub keyword to make an item public. You are not allowed to use private code defined in modules that are children of the current modules. Okay? You are allowed to use any code defined in ancestor modules or the current module. Let me see if I got that straight. Everything by default is private. So if you put it in a module, it is private. If you want to make it public, use the pub keyword. If, like earlier, we were trying to get into these, they were private. If you aren't allowed to use private code defined in modules that are children of the current module. Okay, so sound was not allowed to use instrument and clarinet because they're children of the current module, but they weren't public at the time, so earlier couldn't use them. However, it seems that you are allowed to use any code defined in ancestor modules or the current module. It seems as though if our main function was in like deep in this nested structure, and some of these things, ancestors, were were private, we can still use that code. So, in other words, items without the pub keyword are private as you look down the module tree from the current module, but items without the pub keyword are public as you look up the tree from the current module. Again, think of a file system. If you don't have permissions in a directory, you can't look into it from its parent directory. If you do have permissions to a directory, you can look inside of it and any of its ancestors directories. Okay, I guess that makes sense. So the whole nested in, if you're already in here, then you have the right to look up your ancestor tree. Makes sense. It looks like here they're just going to make things public. They put a public there and still got an issue. They didn't put a public here and everything worked, which we already did that. This will now compile. Let's look at both the absolute and the relative path and double check why adding the pub keyword lets us use these paths in main. In the absolute path case, we start with crate, the root of our crate. From there we have sound. and it is a module that is defined in the crate root. The sound module isn't public, but because main function is defined in the same module that sound is defined in, we're allowed to refer to sound from main. Make sense? Next is instrument, which is a module marked with the pub keyword. We can access the parent module of instrument, so we're allowed to access instrument. Finally, clarinet is a function marked with pub, and we can access its parent module, so this function call works. Okay? The relative path, the logic is the same as the absolute path except for the first step. Rather than starting from the crate root, the path starts from sound. The sound module is defined within the same module as main is, so the relative path starting from the module in which main is defined works. Then, because instrument and clarinet are marked with pub, the rest of the path work. Yada yada yada, they did work the same as above. Next. Starting relative paths with super. You can also construct relative paths beginning with super. Doing so is like starting a file system with the ... The path starts from the parent module rather than the current module. This is useful in situations such as the example below. With a function, clarinet calls the function breathe in by specifying the path to breathe in. Start with super. I see what they mean. So we had another function here. Let's write it here. Function called breathe in. And let's give it a print statement. Call it breathing in. Now, in order to play the clarinet and play sounds, you need to breathe in to start breathing out. But in order to call breathe in, that is in a different module. We have to go up a couple modules, actually. We have to go up instrument and sound, and then we can get access to breathe in. And it seems like we can do that by just using the super keyword, and it knows how to go about finding it. Oh, they have a E at the end of there. Breathe in. Add an E here. I might be spelling breathe in wrong. Meh. Alright. Given that... we should be able to run this. Could not compile sound. And what is the error? Not found in super. That's interesting. It didn't find it. Oh, this is only one level. We're 2 levels in. Does that mean it's super? I'm just want to try that twice. Yeah, actually, okay. So it seems as though super can only bring us up 1 module. In order to go up 2 modules, we need another super. Super, access. That makes sense. Alright. So the clarinet function is in the instrument module. They only have 1 module. We have 2 over here. Just keep a note of that. So we can use the super keyword to go to the parent module of instrument, which in this case is crate, the root. From there we look for breathe in and find it. Success. The reason you might want to choose a relative path starting with super rather than an absolute path starting with crate is that using super may make it easier to update your code to have a different module hierarchy. If the code defining the item and the code calling the item are moved together, for example, if we decide to put the instrument module and the breathe in function into a module named sound, we only need to add the sound module as shown here. So I see what they're saying here. Because we use relative path, this stayed the same. However, if we were using absolute path, before it would have been, let's look up, before it would have been crate / breathe in. now would have been create/sound/breathe in, at least in terms of what the path looks like. Okay. The call to super breathe in from the clarinet function will continue to work as it did before without needing to update the path. If instead of super breathe in, we had used create breathe in the clarinet function, when we add the parent sound module, we would need to update the clarinet function to use the path create sound breathe in instead. Using a relative path can mean fewer updates are necessary when rearranging the module. Using pub with structs and enums. You can design structs and enums to be public in a similar way as we've shown with modules and functions, with a few additional details. If you use pub before a struct definition, you make that struct public. However, the struct fields are still private. You can choose to make each field public or not on the case-by-case basis. In listing 7-11, we've defined a public plant vegetable struct with a public name field but a private ID. Okay, so what they're saying here is that you can use the pub keyword to make structs public. However, even if your struct is public, the fields themselves, you get the option of making them public or not. And in this example, we have the module plant. Within plant, we create a public struct, but we only make the name public. The ID is still private. And then you have vegetable, which, yeah, I can write this out. So we have a new mod called plant, and that doesn't have to be public because it's in the same module as main, so main has access to it, or we can call it from main. But the nested struct does have to be marked as public if we want to use it. Vegetable, and then we have a pub name. This is going to be a string, and we have a private ID, which is an I32. And we have the implementation. We have the implementation block. We have the implementation block here, which is where the functions for this struct will live. Vegetable, and we make them public, or else you don't have access to them either. Oh. Alright, that makes sense. Name, new, name. And this is just a constructor where we're returning a new vegetable. Easy peasy. We pass in what we have there. Name is going to be equal string from name. So they pass in a reference to a string, but then we create a string on the heap so that vegetable has ownership of it. There, that makes sense. And having the ID hard-coded as one is kind of silly, but that's probably like a database thing. Database would define that. We just made it one here for sake of the example. And then let mutable v equal plant vegetable, and then we have the function call for new, and we're passing in the name. We have squash. Can't recall the last time I ate a squash. And then we do v.name is equal, so we're changing the name because the name is, well, we made our variable mutable, so we have access to the public things, and we can change the public things because our variable is mutable. We're exercising that here when we change the name. So string from butternut squash. And then we're going to print the name. Are disgusting. I'm lactose intolerant. I don't do anything butternut. I can't recall eating a squash, so I changed delicious to disgusting. And let's see if you compile. Butternut squash is disgusting. Fix this English. And that sounds like a credible statement. Moving down. Because the name field of the plant vegetable struct is public, in main we can write and read to the name field by using dot notation. We're not allowed to use the ID field in main because it's private. Try uncommenting the line. Oh, they have this line here where we try to access the ID. I'm gonna take the word for it. We can't access it. So it says try uncommenting the line, printing the ID field, and see what error you get, but I believe them. Also note that because plant : vegetable, our struct, has a private field, the struct needs to provide a public associated function that constructs an instance of vegetable. We've used the conventional name new here. If vegetable did not have such a function, we wouldn't be able to create an instance of vegetable in main because we're not allowed to set the value of the private ID field in main. What they're saying here is that this function new is mandatory. The reason why it's mandatory is because if we were to try to instantiate a new vegetable here, write the struct and instantiate it, we wouldn't be able to because we don't have access to this field. So we have to have an associated function, this new, because this new has access to the ID or can at least set it. And because it can set the ID for vegetable, it can now define a vegetable instance and return it. And that's what we're using here. Plant vegetable new. And that gave us our vegetable. Moving on. In contrast, if you make a public enum, all of its variants are public. You only need the pub before the enum keyword, as shown in listing. Okay, so what they're saying here is that if you make this public, all the variants that are listed here are public and you have access to them. That I believe. I'll skip over. Skipping over, and then come down to here. There's one situation involving pub that we haven't covered, and that's with our last module system feature, the use keyword. Let's cover use by itself, and then we'll show you how pub and use can be combined. Alrighty. The use keyword to bring paths into scope. You may have been thinking that many of the paths we've written to call functions in the listing in this chapter are long and repetitive. For example, in listing 7-8, whether we choose the absolute path or relative path to the clarinet function, every time we wanted to call clarinet, we had to specify sound and instrument too. Luckily, there's a way to bring a path into scope once and then call the items in that path as if they were local items with the use keyword. And listing the one right below, we bring the clarinet sound instrument module into the scope of the main function so that we only have to specify instrument clarinet to call the clarinet function in main. So here's the example that they have earlier, sound instrument clarinet, and here's the use of the use keyword. Use create sound instrument, and now instrument is within the scope, and we can say instrument that clarinet. That's pretty straightforward. Yeah, that's pretty straightforward. Adding use and a path in a scope is similar to creating a symbolic link in a file system. By adding use create sound instrument in the create root, instrument is now a valid name in the scope as if the instrument module had been defined in the create root. we can now reach items in the instrument module through the older full paths, or we could reach items through the new shorter path that we've created with use. Paths brought into scope with use also check privacy like any other paths. If you want to bring an item into scope with use and a relative path, there's a small difference from directly calling the item using a relative path. Instead of starting from a name in the current scope, you must start the path given to use with self. And they can show this down below. So yeah, the listing below shows how to specify a relative path to get the same behavior as listing one above. That uses an absolute path. So here they use self sound instrument, and it has the same effect as the one above it, where they use the absolute path create sound instrument. And it looks like just passing in self here, which is going to be relative, has that same end result. Okay, that makes sense. Starting a relative path with self when specified after use might not be necessary in the future. It's an inconsistency in the language that people are working on eliminating. Choosing to specify absolute path with use can make updates easier if the code calling the items moves to a different place in the module tree, but the code defining the items does not, as opposed to when they move together in the chains we made in 7-10. For example, if we decide to take code from listing 7-13, extract the behavior into the main function to a function called clarinet trio, and move that function to a module named performance group, the path specified in use wouldn't need to change as shown below. That was pretty confusing in terms of all the referencing of everything else. I'm not exactly sure what they're trying to say here, but we have an example. And it looks like the example is showing us that this calling doesn't have to change, even though the layout of everything else changed. And this doesn't have to change, even though the layout of everything else changed. So in main, we're calling the performance group clarinet trio, right? We have this mod, which is performance group, which uses this this path, this module, create sound instrument. And then within the clarinet trio, they call instrument clarinet, which is this, which they imported. So because they use absolute path, seemingly this doesn't have to be updated much. In contrast, if we made the same change in the code that specifies a relative path, we would need to change the self to super, and choosing whether a relative or absolute path will result in fewer updates can be a guess if you're not sure how your module tree will change in the future. But your authors tend to specify paths starting with create because code defining and calling items is much more likely to be moved around the module tree independently of each other rather than together, as you saw in 7-10. So what they're saying here is that in contrast, if you use relative paths, then you might have to update more things possibly. Like in the above case, this would have went from self to super because it would have been self in the here, right? But once it's within a module, you have to use super to go up a level. So that would have changed. And they're also saying that people tend to use the absolute path because changes like this are more likely to occur than everything moving together. It seems kind of arbitrary overall. Idiomatic use paths for functions versus other items. Alright. In listing 7-13, this is 16. Well, let me look at 13 before I continue. That's 14. Here's 13. This is what 13 looks like. Sound, instrument, clarinet, absolute path for the use, and then instrument, clarinet. Okay. Go back down. So in 7-13, which we just looked at, you may have wondered why we specified the absolute path, use, create, sound, instrument, and then called instrument clarinet in main rather than the code showing like it's down below and importing all the way down to clarinet and then using clarinet directly. For function, it's considered idiomatic to specify the function's parent module with use and then specify the parent module when calling the function. Doing so rather than specifying the path to the function with use, as this thing showed up here, makes it clear that the function isn't locally defined while minimizing repetition of the full path. Structs, enums, and other fields specifying the full path to the item with use is idiomatic. For example, this thing down here shows the idiomatic way to bring the standard library's hash map struct into scope. So for a hash map, actually for structs, enums, and other types, hash map counts as the type. It is idiomatic to bring that thing all the way into scope, so you could just call it directly, hash map new. However, for functions, it is not. For functions, you want the module. So this would stop at instrument, so you know where it's coming from. That makes sense. Debugging purposes. In contrast, the code in listing 718, this one down here, that brings the parent module of hashmap into scope would not be considered idiomatic. There's not a strong reason for this idiom. This is a convention that has emerged and folks have gotten used to reading and writing it. So this is not idiomatic, going from collections and then doing this long thing. No real rhyme or reason, just the way people write things. Habits. The exception to this idiom is if the use statement would bring two items with the same name into scope, which isn't allowed. And this shows you how you go about doing it. Listing 719 shows how to bring two result types that have different parent modules into scope and refer to them. So here we have standard library format, standard library.io, and they both have results. And we want to bring result into the main scope, but we do that via their parent module. So that and that to make it explicit. Otherwise, Rust, the compiler, wouldn't know which result you're referring to. That's why it's not allowed. If instead we specify use all the way down to result, IO'd all the way down to result, we would then have two results in the same scope and Rust wouldn't know which one you wanted to use. Yeah. Renaming types brought into scope with the as keyword. So it looks like they're going to show us another way to try to solve that problem, which is you have your use, standard, format, result. So import this all the way to result. And then for the next one, instead of importing as result, you can use the as keyword to change the name you use to access this result. And then put that there. And this is also considered idiomatic, at least according to this sentence. Alright, next. Re-exporting names with pub use. Okay, so now we're going to combine the use of pub and use, or at least these two keywords. When you bring a name into scope with the use keyword, the name being available in the new scope is private. If you want to enable code calling, your code to be able to refer to the type as if it were defined in the scope, just as your code does, you can combine pub and use. This technique is called re-exporting because you're bringing an item into scope, but also making that item available for others to bring into their scope. Okay, so I think what they're saying is Let me see here. No. I see the mod sound, instrument clarinet. Here we have pub use, instrument clarinet, absolute path defined for you. We use it here, which is also public. And down here we use clarinet trio, and here we go. Understood. So what they're saying here is that if you use public here, then this is now public for other people in other scopes. So because main has access to performance, and this is also public within performance, I now from main can directly call performance group instrument clarinet. And that's solely because this is public. If it was not public, then it would be like before, and this line would be gone. Okay, that makes sense. They're saying what I just said. Cool. Using external packages. In Chapter 2, we program a guessing game. That project used an external package called rand to get random numbers. To use rand in our package, we added this line to the cargo TOML file. Dependencies, rand, and I can confirm that we did. If you want, you can check out that video. Guessing game. Okay, this is, I guess, external. Adding rand as a dependency in the cargo TOML file tells cargo to download the rand package and its dependencies from https://crates.io, so crates.io, and make its code available to our project. Then, to bring rand definitions into the scope of our project, we added a use line starting with the name of the packets. Then, to bring rand definitions into the scope of our package, we added a use line starting with the name of the package, rand, and listing the items we wanted to bring into scope. Recall that in the generating a random number section in Chapter 2, we brought this thing, RNG trait, into scope and called the rand thread RNG function. So we did use and rand right there. This thing. So I do remember doing that. However, I'm not exactly sure what that was. I didn't know this was a trait at the time. At least right now I can't recall if it was. There are many packages that members of the community have published to crates.io, and pulling any of them into your package involves these same steps. Listing them in your package cargo TOML file and bringing items defined in them into scope in your package with use. Note that the standard library, std, is also a crate that's external to your package. Because the standard library is shipped with the Rust language, you don't need to change the cargo TOML file to include std, but you refer to it in use to bring items the standard library defines into your package's scope, such as with the hash map. So what they're saying here is that the standard library is also external to your program, your package. However, since that is shipped with the language itself, you do not have to define it in your cargo file. It's already there for you to import and use, but you still have to import it. Like with the hash maps, you import it using the use and standard collection hash map. This is an absolute path starting with std, the name of the standard library crate. Nested paths for cleaning up large use lists. Okay. When you use many items defined by the same package or in the same module, listing each item on its own line can take up a lot of vertical space in your file. For example, these two use statements we have in the below listing in the guessing game. Well, actually not in the below listing, it's a snippet. So here we have use standard compare ordering and use standard library IO, which if you wanted to, we could nest them because taking up vertical space, put them into one line. We can use nested paths to bring the same items into scope in one line instead of two by specifying the common part of the path, then 2 colons, then curly brackets around a list of the parts of the path that differ, as shown right here. So this can be rewritten as this: standard library : and then the parts. The first one is this one, comparing ordering, and comma. The next part is IO. In programs bringing many items into scope from the same package or module, using nested paths can reduce the number of separate use statements needed by a lot. We can also deduplicate paths where one path is completely shared with the part of another path. For example, down here. So deduplicate. What they're saying here, at least what I believe, is this path is standard library.io. This path is standard library.io.write. This path is within this path, or vice versa, depending on how you look at it. But we can rewrite it using the one-liner syntax thing. And we say self for this and write for here. That makes sense. That makes sense. So you don't have to write both of them out. Bringing all public definitions into scope with the glob operator. If you like to bring all public items defined in a path into scope, you can use specify that. You can use specify? I read that like 3 times and that doesn't sound right. You can specify that path. There's 2 errors on this page. Okay. You can specify that path followed by a star, the glob operator. So what they're saying is that if you want to import multiple things or all the public items for a specific path, you can just use a star operator and that just globs everything in. So for here in collections, it's going to import everything that's public within collections. So they're probably going to say that here. This use statement brings all public items defined in standard library collection into the current scope. Be careful when using the glob operator. It makes it harder to tell what names are in scope and where the name your program uses was defined. So yeah, you should always be careful with this. It's a code smell. If you import too many things, if you import everything, you're not exactly sure what you're using. There's no sort of inventory, no way of necessarily going back, looking at the code directly and being, I'm using that one, because the names aren't there. And 2, in terms of just taking inventory, you always want things to be smaller. Less things you import, the less chances are for errors and yada yada yada, especially if you're importing code that you don't trust. The glob operator is often used when testing to bring everything under test into the test module, but we'll talk about that in the how to write test section of chapter 11. The glob operator is also sometimes used as part of the prelude pattern. See standard library documentation for more information on that pattern. Yeah, I'm not sure what that prelude pattern is. Prelude, I believe, if I recall correctly, is everything that is defined and imported for us. For example, there are things that we use like print, string definitely is imported for us. When I say string, I mean this string. That's part of the standard library, but we don't import it. They do it for us. I believe that happens there. Just curious where this link goes. Oh, open this real quick. It looks like it goes directly to Preludes. All right. Preludes can be seen as a pattern to make using multiple types more convenient. As such, you'll find other preludes in the standard library, such as Prelude. Various libraries in the Rust ecosystem may also define their own preludes. The difference between the prelude and these other preludes is that they are not automatically used and must be imported manually. This is still easier than importing all of their constituents. constitute. This is still easier than importing all of their components. And here's the list of things that are imported for us, at least in the prelude. Here's string and toString. Vect we haven't used yet, but that's there. Option is already here, which we have used. I don't think we used these. Some of compares here, but not the one we wanted before. Clone box drop. Okay. So these are things that are imported for us. And it looks like if you want, you can, when you're writing a package, you can write your own prelude. But somebody using it still gonna have to import it. Okay. Separating modules into different files. All of the examples in this chapter so far define multiple modules in one file. When modules get large, you may want to move their definitions to a separate file to make the code easier to navigate. For example, if we started from the code listing in 7.8, we can move sound into its own file called source sound by changing the crate root file, in this case main, to contain the code showing this. Mod sound, and then create sound, and we're still calling it. And then in the sound file, because we moved that stuff out to its own file, we have this IC. So the source/sound.rs gets the definition from the body of the sound module. Using a semicolon after the mod sound instead of a block tells Rust to load the contents of that module from another file with the same name as the module. So this line right here, because it's a semicolon, doesn't have a block, this is telling Rust to load this module, and that this module is going to have the same name. The file that has this stuff is going to have the same name as this sound, which they have here. To continue with our example and extract the instrument module into its own file as well, we change sound, source sound, to contain only the declaration of the instrument module. Okay, so if we were to do it this way, sound.rs defines instrument. We now have the sound directory, and we have instrument.rs within the sound directory. That makes sense. So we still have that file, and we have a sound directory. Okay, just a file system. The module tree remains the same, and the function calls in the main continue to work without any modification, even though the definitions live in different files. This lets you move modules to new files as they grow in size. And now we got to the summary. Summary. Rust provides ways to organize your packages into crates, your crates into modules, and to refer to items defined in one module from another by specifying absolute or relative paths. These paths can be brought into a scope with a use statement so that you can use a shorter path for multiple uses of the item in that scope. Modules define code that's private by default, but you can choose to make definitions public by adding the pub keyword. Next, you'll look at some collection data structures in the standard library that you can use in your nice, neat code. And just to verify, so the next section is common collections, and we'll go over vectors, strings, and hash maps. Alright, well, that's the end for this video. I hope it was enjoyable, I hope it was useful, and I'm gonna go to bed. Peace.